Okay, so in section 6.6, we are going to learn how to solve absolute value inequalities. So a lot of the things that we learned in the previous sections are going to come up here, so this goes well together. So in the previous section, 6.5, we learned how to solve absolute value equations, and that's what we're going to start with here. So the most important thing is to rewrite the absolute value inequality. So I'm going to remind you how to rewrite absolute value equations. So remember that absolute value tells you the distance away from 0. So this right here means that the distance away from 0 is 5, which means that it could either be at positive 5 or at negative 5, because the absolute value just tells you how far you need to be. So I could be 5 units to the left, or I could be 5 units to the right. So the rewriting part is how we are going to get rid of the absolute value bars. So the first equation is x minus 7 is equal to positive 5, or x minus 7 is equal to negative 5. And notice that once I rewrite, I don't have the absolute value bars anymore. For this one here, the statement says that the distance away from 0 is more than 5. So if you think about this, here's 0, here is going to be where the 5 units away will take us, and we have to be further away because the distance has to be more than 5. So I have to go further away, so to the right of positive 5, or I could also be at negative 5, and my distance has to be more than 5, so I have to go further away. So this is an OR problem. And the first inequality is going to be x minus 7 being greater than or equal to positive 5, which is going to go with this part of the picture. Or it's the x minus 7 is smaller than negative 5, and that's going to go with the left side of the picture. So all the numbers that are smaller than negative 5. For the last one, we have distance away from 0 has to be less than 5. So here is a 5 and here is a negative 5. The distance has to be less than 5. So I have to be within 5 units away from 0. So I could be anywhere between a negative 5 and a 5. So think of this as a sandwich in between, where you have to be between negative 5 and positive 5, and this 5 came from here, so it's always going to be the same number and the opposite. Your inequality sign is going to go this way, because if you think about the number line, the larger numbers go to the right, and then my x minus 7 is just going to go over here. So I'm going to point to a couple of things in here before we move over to the next slide. So here's my x minus 7, and my x minus 7 was here. It doesn't change, it stays exactly the way it is. Here I had an x minus 7, and I'm going to keep it as x minus 7 here. I have an x minus 7 over here, and I have an x minus 7 and another x minus 7. And that's it. So this is going to be the most important part. If you can't rewrite it, you are going to have everything else incorrect. Okay, so what I want you guys to do is I want you to pause this and try to rewrite on your paper each inequality or equation, and then hit play to check whether your answers are correct. Okay, so the first one is going to be an OR problem, because distance has to be more than 53. So it's going to be negative 3 plus 5v being greater than or equal to 53, or negative 3 plus 5v being less than or equal to negative 53. Over here, the distance has to be less than 21. So this is your sandwich in between, and you're in between negative 21 and 21. And then negative 3 plus 3n goes in the middle. And that's all you have to do for the rewriting part. The third one is an equation. So the distance away from 0 is exactly 30. So that means that 8x plus 10 can either be equal to positive 30 or it could be equal to negative 30. This is an OR problem. So 8a minus 1 is either greater than 49 or it could be less than negative 49. This is again an OR problem. 2n minus 7 can either be bigger than 9 or smaller than negative 9. Now I want to just point out something with all the OR problems. So what's going to happen is the first inequality is going to pretty much stay consistent with what you see here. And in the second inequality, our inequality sign will switch and the 9 becomes a negative. Over here, our inequality sign changed and the number became opposite. Over here, our inequality sign changed and this became the opposite. So the second part of the OR rewriting will always have a different inequality sign as long as you have this expression on the left, and then you're going to have the opposite number. Alright, so let's continue. 3x minus 1 is equal to 4. Means that the distance away from 0 is exactly 4. So 3x minus 1 can either be equal to positive 4 or 3x minus 1 can be equal to negative 4. Okay, so over here, this is distance being less than 31, so this is an AND problem. So we are going to be in between a negative 31 and a positive 31. We don't need an equal sign. And then negative 9v plus 4 is going to be in between. The last one is an equation. Distance away from 0 is exactly 26. That means that 6 minus 2n can either be equal to 26 or 6 minus 2n is equal to negative 26. Okay, so that's it for the rewriting part. So now we're actually going to start solving. Now, what I want you guys to remember, I'm going to put the slide in here. I want you to write this on your test paper whenever you deal with absolute values. So these are the 3 steps that you need to follow, and it needs to be in this order. So the I stands for isolate. You always want to isolate the absolute value. So if it has 2 multiplied by 8 or 3 added to the end, you will have to first isolate, meaning get the absolute value by itself. And only then can you actually continue with the solving. So isolate first. R stands for rewrite, which is what we just did on the previous slide. And only after you isolate and rewrite can you actually start solving to finish up the problem. So keep remember, IRS. Okay. So the first example is going to have us solve an inequality. So remember, these are our 3 steps. Isolate. The absolute value is already isolated, so we don't have to worry about this. This is already done for us. We do need to rewrite it. So we need to think about whether it is an OR or an AND problem. So the distance away from 0 has to be greater than or equal to 6, which means that I have to be further away from 6 or further away from negative 6. So my rewriting part is going to look like this. X is greater than or equal to positive 6 or X is less than or equal to negative 6. So that is going to be our rewriting. Now the solving is when we get the X by itself. If you notice, it's already by itself, so we don't have to do this. This is already done for us. So this is your answer right here. The only thing I need to do is I need to graph the solution. So since we do have an equal sign, it will have a filled-in circle that goes to the right, and negative 6 where the inequality goes to the left. So it should really look like an OR type of problem. Part B is already isolated. We do have to rewrite it. The distance away from 0 has to be less than or equal to 0.5. So this is where X is in between the negative 0.5 and a positive 0.5. Our bigger numbers are always going to be on the right side. and whatever is inside the absolute value just goes in the middle. So in this case, it's just x. So we rewrote, and we don't have to solve because x is already by itself. So it's solved for us, so we're done. So our graph is going to look like this. So two filled in circles, and this is going to be in between. Alright, so try these three on your own and see how you do. In this example, we have to solve an absolute value inequality that has one step inside the absolute value bar, so we have to solve. I'm going to write our 3 steps: isolate, rewrite, and solve. It is already isolated. There's nothing next to the absolute values. It's by itself. I do need to rewrite. Since the absolute value is greater than or equal to 7, it's an OR type of problem, which means that x minus 5 can either be to the right of 7 or it could be to the left of negative 7. So that's the rewriting part. I do need to solve, so what I'm going to do is add 5 to both sides, which gives me x is greater than or equal to positive 12. Or I need to solve the second inequality, so I'm going to add 5 to both sides and get x is less than or equal to negative 2. So this is my answer. There's nothing else I need to do. I finished my 3 steps, and I just need to graph it. So on the number line, 12 gets a filled in circle, and x has to be greater than or equal to 12, so we're going to go to the right, or negative 2 gets also a filled in circle, and we're going to take a look at all the numbers that are less than negative 2, so it's going to look like this. So now try these 2 problems. Notice that one of them has a greater symbol, one of them has a less than symbol. So you'll definitely have an AND problem, and then you will also have an OR problem. Okay, so in example 3, we are going to actually use our IRS to complete all 3 steps. First, we need to isolate the absolute value. There's a plus 3, which means that it's not isolated. We have to get rid of this plus 3 first. So subtract 3 from both sides, and we get absolute value of negative 4x minus 5 less than 6. So I isolate it. Then we are going to rewrite. The distance away from 0 has to be less than 6. So this is an AND problem, and my number, or my expression, is in between a negative 6 and a positive 6. My inequality is going to be opening up towards the right, and this negative 4x minus 5 just goes in the middle of your inequality. So we just rewrote. We need to solve, so we need to get, remember that when you solve, x needs to be in the middle all by itself. So first we're going to add 5, and if we add 5 to the middle, we have to add 5 to the left side as well as the right side, because our inequality has 3 parts to it. So negative 6 plus 5 will give us negative 1. Our negative 5 and positive 5 cancel here. And then 6 plus 5 gives us 11. So then, I do need to keep working because x is not by itself. I am going to divide by negative 4. As soon as you realize that you have to divide by a negative number, I want you to remember that you do have to flip the inequality sign. So before you do anything else, you flip and then proceed. So we are going to get x by itself by dividing everything by negative 4. So this number is 1 over 4. X is in the middle. I'm just going to use the red color so it's consistent. So we get 1 over 4 x and negative 11 over 4. So 1 over 4 is our largest number, so it's right here. And then negative 11 over 4 is our smaller number, and this is going to be a number that's almost negative 3. And x is going to be everything in between. So this is going to be, so we solve. This is our answer. and then this is our graph. If you rather have your answer follow the number line, you can also write this. Both answers are correct. It is your personal preference. So you can either use this answer or you can use this as an answer. Both of them are correct. Okay, so pause the video and try this last you try example.